Right, so it says the position vectors of points A and B relative to a fixed origin O are given by this here, right? Now what I do here, right, for part one, it says find AB bolded. Okay, so if it's bolded, it means a vector. They want the vector AB. A sketch is what you really need here, okay? Because they give you, don't they? They give you the vector of A and the vector of B relative to the origin, okay? That's why they're called position vectors, okay? So they're a bit more special than normal vectors. They're position vectors because it's telling you how to get to them from the origin. It's a bit like coordinates then, really, isn't it? Okay, so when you see position vectors, it's giving you the coordinate, okay? Or in this case of A and B. So you've got to go from O to A, okay? It will be that vector there, I plus 3j. You know, you can think of it as going across 1 up 3, okay? Because I represents across, J represents sort of going up, you know, with an X and Y axes. Similar then for B, okay, 3I plus 6J, so you're going across 3 up 6. All right, now my sketch doesn't necessarily reflect that because I've got it going down here with B, but that doesn't matter, right? It's a sketch. We only do a sketch just so we can understand, in this case, how to get the vector AB. Now, appreciate here, vector AB is taking you from A to B, okay? So I need to have an arrow like that there, okay? Because I essentially want to get from A to B, okay? And, you know, when we write it down, we can't obviously bold this. So what I do is I put an arrow above, okay, to show that this is a vector and I want to go from A to B. Now, I don't know what it is, okay? I don't know what it is in terms of I and J. And that's what they want here. They want the vector in terms of I and J, all right? But the good thing is here, the good thing is, we know what OA is, we know what OB is. OA is simply the position vector of A, which is that, and OB is the position vector of B, which is this. So to get AB, what I can do is think of the combined route of going, instead of going from A to B, I can go from A to O, and then O to B, okay? So A to B is A to O, plus O to B. Now, you need to appreciate the fact that A to O is like the reverse. It's the reverse process of going from O to A, yeah? It's going backwards, isn't it? When you go from A to O, you're going back to the origin. So if it's the reverse process of O to A, I can say A to O is simply minus of O to A. It's the reverse process of it, okay? You're going backwards. So put a minus in front of it. Plus O to B. And that's what AB is. And you know, a lot of people like to then rewrite this as OB, take away OA, okay? Because it's minus OA. So we chuck that first and then take away OA. So it's the position vector of B, which is 3I plus 6j. Take away then the position vector of A, which is I plus 3j. Now, careful here not to make the mistake that I could be making if I don't correct it. I need to take away, don't I, the position vector of A, which is this here, okay? So I need to take away all of it. So put it in a bracket. Because if I didn't put a bracket, when I'm taking away here, you might only apply that minus to the I. You've got to apply the minus to all of OA. So in fact then this becomes 3I plus 6j minus I minus 3j. Okay, so minus applies to the 3j as well. Simplifying it, we get, well, 3I take away I is 2I, and 6j take away 3j is 3j. Okay, so we group the i's, group the j's. There is my vector A to B. Part 2 then, it says calculate the length of the line AB. So that's what we want to do. But remember now, AB is simply this vector here. Okay, right? Go along that vector, okay, from A there, and we get to be 2I plus 3j. So we want to get the length of it. It's sometimes useful to appreciate what 2I plus 3j actually means. Remember, 2I simply means 2 across, yeah? Because I is just a unit vector, okay? Unit just means of length 1. in the x direction. So we're going 2 across and then 3 up. Okay, so you can kind of think of it like that, and it gives you then where you end up. So you start here, you end up there. Okay, so we can look at 2i plus 3j now as going across 2 up 3. So you start here, end up there. To work out the length of that, of course, if you think about it, we could use Pythagoras, yeah? Because we know these two sides, we can work out the third side, that being a right angle triangle. So I need to square these two sides here, 2 squared plus 3 squared. And of course then you square the other side, don't you? Okay, so in this case then, it's AB, okay, the vector AB. Now because I'm working out the size of it, I often put bars around it as well, right, to show us the size of it, but we're going to square that as well, aren't we? Okay, and what you get then is, of course, to work out what AB, the size of it is, you could take the square over and square root. So we can do all that in one go, can't we, on our calculator? And we get then what this is here. Now, I don't have to write that underneath now. I could just write AB, okay, because this gives me the length there. So my calculator comes out to be square root of 13. So that's what the length is there.